Okay, moving on to calc assumed, question 8. Particles A and B moving with constant velocities have initial positions that, and 2 seconds later A is there. Okay, so A is moved from here to here in 2 seconds. This is the initial position, this is the final position, and they want us to work out the velocity of A. So obviously the velocity of A is whatever it's moved. So it's moved all the way from, so you do final position, take initial position to find out what its displacement vector is. -8 to 10, that would be its displacement vector, and if we divide it by 2 seconds, that should give us the velocity vector. So 0, take 8, divide by 2 is 4, -2, take 2 is -4, -4 divided by 2 is -2, 4 take 10 is -6, -6 divided by 10 is -3. Okay, so that is the velocity vector of A, that many meters per second. All right, the velocity of B is this. Show that the paths of A and B cross, and then explain whether the particles will collide or not. Okay, so I'm just going to start off with this. So where is A at any point in time? What is the position of A at any point in time? I'll just say RA. The position of A at any point in time is where it starts. It started at -8 to 10. So -8 to 10 plus t lots of its velocity vector. So its velocity vector is, we just worked out to be 4 minus 2 minus 3. All right, so that is where A is at any point in time. Now, where is B at any point in time? So B starts at 7, 7, -15. So B starts at 7, 7, -15. And it moves t lots of velocity vectors. So t lots, and its velocity is 1, -3, 2. So it moves t lots of 1, -3, 2. That's where B is at any point in time. Okay, now generally, when you're trying to find out where two things collide, you just let position of A equal position of B. But this is not asking just for collision. It's first asking, show the paths cross. All right, so that's a different thing. Showing paths cross is different to showing that the particles collide. So if you want to know whether the paths cross, you can't have them both have the same parameters. It has to be like T1 or T2. Or what I prefer, rather than T1, T2, I can write lambda and mu. So this can be lambda, this can be mu. So we let these two equal each other. Position of A equals position of B. So where is it A at any point in time? We're just going to group it all together with the lambdas. So A at any point in time is -8 plus 4 lambda, or 2 take 2 lambda, and 10 take 3 lambda. That's where A is at any point in time. And where is B at any point in time? Just merge it all together. So 7 plus mu, 7 take 3 mu, and then -15 plus 2 mu. All right, I hope you guys realize that there are two unknowns, lambda and mu, despite that 3 equations, the i's, the j's, and the k's. Alrighty, so there is something I want you to understand about this. If you want to find out whether it paths cross, or whether it collides, or whether it doesn't do either, these are the steps that we follow. First, you solve simultaneous equations 1 and 2. All right, you solve simultaneous equations 1 and 2. So in this particular case, simultaneous equations 1 and 2 will be, well, number 1 will be this. -8 plus 4 lambda is 7 plus mu, and then 2 take 2 lambda is 7 take 3 mu. So we're going to first solve the first two simultaneous equations. What have I said? That if there is no solution, the paths do not cross. Straight away, the paths do not cross. However, if there is a solution to your simultaneous equations, then check if the solution is consistent with equation 3. All right, so first let's just solve these two. So we have to solve these simultaneous equations. -8 plus 4 lambda is 7 plus mu, and 2 take 2 lambda is 7 take 3 mu. So if I put that into simultaneous, what will I get? There you go. You can see that instead of using lambda and mu, I've just used x's and y's. -8 plus 4 lambda is 7 plus mu, and 2 take 2 lambda is 7, take 3 mu. We get lambda equals 5, mu equals 5. Lambda equals 5 and mu equals to 5. So the first thing that I need to do, there is a solution. So if there is a solution, I need to check if the solution is consistent with equation 3. If it is not consistent, then paths again do not cross. However, if it is consistent, paths do cross. So let's check whether this solution is consistent with the final equation. 10 take 3 lambda is minus 15 plus 2 mu. 10 take 3 lots of 5 is minus 15 plus 2 lots of 5. 10 take 15 minus 5, minus 15 plus 10, also minus 5. Perfect. So our solution is consistent with equation 3. So therefore, the paths of the particles cross. The paths cross simply means that at some point they'll both be here. Now they don't have to necessarily be there at the same time. It just means that at some point both particles will have a crossing path. So maybe one will be there to begin with, and then a little bit later on the other one will be there. All right, what's the next thing that I've written? If your lambda value is the mu value, is not, if lambda does not equal mu, it means the paths cross at different times. What I'm trying to say is it means they do not collide. However, if lambda is mu, it means the paths cross at the same time, which means they do collide. What did we get? Oh, we did get lambda equals mu. So we can write that lambda equals mu equals 5. So not only do the paths of the particle cross, we can say therefore the particles collide at t equals 5. Alright, which means after 5 seconds at t equals 5. What is the question asking for? Show whether they cross, state the position vector of this point, and whether they collide. Okay, so I just need to find out the position vector of this point. So I just need to chuck 5 either into here or into here, either or. Okay, so we'll just find out what happens when we put 5 into here. So the position of A at t equals 5. Minus 8 plus 4 5s are 20. 2 take away 2 5s are 10, and 10 take away 3 5s are 15. Okay, so therefore they intersect at minus 8 plus 20 is 12, negative 8, negative 5. 12, negative 8, negative 5 is where the paths of these particles cross. Easy. Alright, so that is important for intersecting or crossing paths or collision of two moving particles in 3 dimensions. Question number 9. A particle moves in space with position vector this. Fine. Determine the distance of the particle from the initial position after pi on 4 seconds. Alright, all we have to do is sub in t equals pi on 4 to find out where is the particle after pi on 4 seconds. So 4 times pi on 4 is just pi. Minus 5 cos 2 pi on 4. So 2 pi on 4 is pi on 2. Cos of pi on 2 is 0. So that one's just 0. And then 5 sine 2t. So 2 pi on 4 is pi on 2. Sine pi on 2 is 1. Okay, so that's where it is at pi on 4. Now we want to know the distance of the particle not from the origin. We want to know the distance from the particle from its initial position. So we also need to work out where it was to begin with. If it simply said where is the particle from the origin, I would have just found out the magnitude of this vector straight away, but we don't want that. All we need is the magnitude of, we want to know how far it is from its start point. So where does it begin with? 4 times 0 is 0. Cos of 0 is 1, so it starts at -5, and sine of 0 is 0. So that's its starting point. So therefore, basically the displacement vector in those pi on 4 seconds is just 1 take the other. Doesn't matter which way around you take it. So pi, 0 take 5 is 5, and 5 take 0 is 5. So that's the displacement, but we want the distance. So the distance is just the magnitude of that. So square root of pi squared plus 5 squared plus 5 squared. All right, if you want to give that exact, I guess that's square root of pi squared plus 50. I guess you can put that into your calculator and get a decimal approximation. A decimal approximation is 7.74 centimeters. All right, that is the distance. It has not the distance that it has traveled, but the distance from the initial position. Okay, that is the distance from the initial position. I better not. There's a big difference between distance traveled. Does it even ask for distance traveled at any point? It doesn't ask for distance traveled. So I'm just going to tell you the difference. There is a difference between distance from the initial position. In fact, I'm going to just write down everything that we need to know. So if you want to know the distance traveled from T1, distance from its position at T1 and its position at T2. The formula for the distance of its position from T1 to T2, you just work, which is what we're doing over here. That's what this question here is. We're trying to work out the distance of from where it is from a certain time to a certain time. So all you do is work out the vector of the displacement vector, and then you work out its magnitude. So that's how you find out the distance from two positions at two different times. If you want to work out the distance from the origin, at a specific point in time, all right, at a specific point in time, all you do is work out the magnitude of its position vector at that point in time. And lucky last, if you want to find out the distance traveled from T1 to T2, you actually want the curved distance traveled rather than just the straight distance between them. If you want the distance traveled, what you do is you actually integrate the velocity vector, not even the velocity vector, the speed vector. So the speed vector is the magnitude of the velocity vector from T1 to T2. I'm sure that's going to come up at some point, but these are the three formulas. One is distance. These are all the three distance formulas. The distance between 2 points, or the distance from the origin, or the distance actually traveled from T1 to T2. These are the three formulas we need to know. All right, show the particle is traveling at a constant velocity. So we all know that the velocity is just the derivative of displacement. So the velocity vector is 4. Derivative of negative 5 cos 2t is 10 sine 2t. And 5, this is 10 cos 2t. That is the velocity vector. I just need to show that the speed is constant, and we all agreed that the speed is the magnitude of the velocity. So the speed is just the magnitude of the velocity vector. So all we have to do is work out the magnitude of that velocity vector. To be a bit more specific, this is velocity in terms of t. So if you really wanted to be like mathematically correct, not correct, but more polite. All right, we're going to work out the magnitude of the velocity vector and show that it's constant. So it's 4 squared plus 10 sine 2t is 100 sine squared 2t plus 100 cos squared 2t. Ah, that's perfect, because we know sine squared t plus cos squared t is 1. If sine squared t plus cos squared t is 1, 100 sine squared t plus 100 cos squared t is 100. So we have square root of 4 squared, which is 16, plus 100, which is square root of 116. Now the point is that it is a constant value, independent of time. So we can say that speed is independent of time, aka therefore the speed is constant. Very easy question. Next one. All right, at time t seconds, the position of a particle is given by this. State the position vector of the point that the particle approaches as t approaches infinity. Now this is just knowledge that we're meant to know from year 12 methods content. So in year 12 methods content, let's say for example, we all know what e to the x looks like. You all should know that e to the x looks like this, and that's the way it goes, and there's an asymptote here. You should also know that e to the negative x looks like this. This is what e to the negative x looks like. If this is e to the x, this is e to the negative x. Now, what do you guys notice? E to the x is still approaching a value of 0. I guess what I'm trying to say is we just need to know that e to the negative infinity basically approaches 0. It's okay, it's as good as 0. All right, I'm just going to write is 0. Technically approaches 0, but honestly doesn't make a difference. So state, that knowledge is important here. State the position vector of the point that the particle approaches as t approaches infinity. So if I sub in t equals infinity into here, I just told you that e to the negative infinity is 0. So this is 10 e to the negative infinity plus 5, and this is 15 take 20 e to the negative infinity. We just agreed that e to the negative infinity is 0. So that makes this top thing 5, and it makes this bottom thing 15. So there you go. That's the position that the particle will approach, blah, 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 meters. Determine the speed when t is 5. Okay, another very easy question, a bit repetitive of the previous one. So first we find out the velocity vector by differentiating. 10 times minus 0.4 is minus 4. E to the minus 0.4t. And this one would be 20 times by that is 16. E to the minus 0.8t. Okay, that is the derivative of the position equation. So that is your velocity equation. We want the speed when t is 5. So we can just sub t equals 5 into here. So when I sub t equals 5, you can keep it exact if you want. So that's minus 4e to the negative 0.4 times 5 is neg 2. And negative 0.8 times by 5 is negative 4. So that is the exact velocity expression. We want the magnitude of that velocity expression because we want the speed. So speed is simply equal to the magnitude of the vector that we just located. Negative 4e to the minus 2, 16e to the minus 4, easy. And obviously we just have to Pythag to find out the speed. Speed equals root that squared, so that would be 16e to the negative 4. And this squared would be 256e to the negative 8. All right, I guess if you want, does it even ask for exact speed? No, it just says to the nearest 0.001 second. So put that straight into your calculator and you'll get 0.616 meters per second. All right, express the Cartesian equation for the path. Okay, that again looks pretty straightforward, the Cartesian equation. So if it says Cartesian equation for the path, you always look at the position, not the velocity, not the acceleration, you look at the position vector. So the x value of the position vector is this. All right, the y value for the position vector is this. Now, we just need to get rid of the t. What's a nice way to get rid of the t? What's a nice way to relate the two equations to get rid of the t? Now, just have to be a little bit good at mathematic manipulation. You need to see this. E to the negative 0.4t, e to the negative 0.8t, they all look a little bit familiar. So what you can do is this. You just have to see it. Okay, you either see it or you don't. So first, I'm going to just rearrange for e to the minus 0.4t. Okay, and then I'll rearrange for e to the minus 0.8t. E to the minus 0.8t means that you bring the y across and then divide by 20. Now what you need to realize that e to the minus 0.8t can be written as e to the minus 0.4t squared using your indices rules. Ah, that's perfect, because now you have an expression for e to the minus 0.4t. You have an expression for it. It is x take 5 on 10. So I can just write x take 5 on 10 squared equals 15 take y on 20. Perfect. And what do I have to do? They want it in the form y equals something. So that's also pretty straightforward. Bring the 20 across. So 15 take y is 20 lots of what we just said. I think we can simplify that. So that's 20 lots of x take 5 squared over 100. And then just simplify that, bring the y across. So the final answer is y equals 15 take x take 5 squared on 5. So that would be an expression for its position at any point in time. They don't really want an expanded version, so honestly, that should do the job fine. Now, is there any catches to this? Is there a catch? Let's have a look, because always remember, when you do this, you lose information about time. Remember, we lose information about time. So I'm just trying to see if there's a catch to this. So I'm just going to look at the, so look, we can use this to work at the domain. We can use, what do you guys notice is the domain of the x value? What do you guys even know what this graph looks like? So this graph, you can see that at any point in time, x is this, right? X is 10e to the minus 0.4t plus 5. Now, you should be able to use your methods knowledge to be able to sketch that. All right, so according to our methods knowledge, there is a horizontal asymptote at 5. And since it is a positive a value and a negative b value, the shape of the graph is as such. So the shape of the graph looks like this. Now, having said that, time has to be positive. Remember, this is the time, and this is, I guess, its x value at any point in time. Time must be positive. So since time must be positive, I must cross out this part of the graph. All right, I must cross out that part of the graph, because that part of the graph just doesn't belong. Okay, so if I know that's what the graph looks like, then all I need to know is what's it eventually approaching? It's eventually approaching a value of 5. So that's the value that it's approaching. The asymptote here was at y equals 5. And at the same time, theoretically, time cannot be negative. Hence, you cannot have all these x values here theoretically. All these x values above this does not exist. So what x value would this be? When you sub 0 into here, e to the 0 is 1, 10 plus 5 is 15. Okay, so what I'm trying to say is that I used my position, my x. I used my x. Why am I using x? Because the domain is all about the x. Domain is all. I could have easily done something similar with y, but y would have related to the range. So we have to do something with the x. So you can see that I graphed my x value in terms of time. I got rid of all my negative x values, and then I've noticed that x is therefore between 5 and 15. X is between 5 and 15, and that's important because this is not the final answer, because according to this seems to imply that x can be anything. All right, as soon as you got rid of the t, you lost information. As soon as the time was, I guess, substituted out, we lost information about time. So I always look back and see whether I need to give a suitable restriction to the domain. I reckon there'll be quite a few kids that would have forgotten to give a suitable restriction for the domain. So yes, that is y equals x at some point in time, but I must write comma. The restriction is that we'll approach, I don't know why I wrote y as phi, I guess because it's a horizontal asymptote. Theoretically, it's like x equals 5 because this is the x-axis, whereas this is the time axis. So at some point, it will be 15 and it will approach 5. So I better write comma that the x value is somewhere between 5, not inclusive, and 15 inclusive. All right, a lot of people would have lost the mark for the domain. But now you guys understand that yes, you can give Cartesian equations, but check whether you need to apply a suitable restriction to your domain. All right, question number 14. Relative to an origin, a projectile is launched. Okay, another vector calculus. A lot of vector calculus in this one. It's launched from 0, negative 9.5 meters. Initial velocity this. The motion is only affected by constant acceleration. Derive from the acceleration an expression for the position vector. All right, this is a very vanilla question. This comes up all the time. So the acceleration vector is 0, negative 9.8. Okay, that is the acceleration vector. So to get the velocity vector, we just have to anti-differentiate that. Integral of 0 is 0. Integral of this is minus 9.8t plus the vector c, okay, plus the c vector. Now, are we told anything about the initial velocity? Yes, the initial velocity is this. So we are told that the velocity at t equals 0 is 1235. So let's sub that in and find c. I've got a feeling that c is exactly that vector. So if I sub in 0 into this expression, we get 0, 0 plus c. I had a feeling. So guys, what that proves is the c vector. The c vector is 1235. which means that we can rewrite this nicely as the velocity at any point in time. It's the top is going to be 12 and the bottom is going to be minus 9.8 t plus 35. Alright, so that was easy so far. So that's the velocity. So then to find the position vector, we just antidifferentiate that one more time. So the antiderivative of 12 is 12t, and the antiderivative of this is just minus 4.9 t squared plus 35t plus c again. I'm just going to write plus d so we don't get confused with the other one. Alright, what is the initial position? It's launched from this point. So that's the initial position. I'm sure that's actually going to be the c value. I'm very confident that's going to be the c value. We're told that r at t equals 0 is 9.5. So we can just sub in 9.5 into this expression. 9.5. And if we sub 0 into here, we're lucky. Now remember, it's not always the case. Just because it's subbing in 0 doesn't always give you 0. But in this case, it does. So this is 0, this is 0, plus the vector d. Perfect. Which means, guys, that at the end of the day, the d vector is 9.5. Okay, so 0i plus 9.5j is the d vector. Which means that we can rewrite this. We can rewrite this as the position at any point in time is 12t plus 0, so no need to write that. And this one is minus 4.9t squared plus 35t plus 9.5. All right, honestly pretty easy. Meters. All right, this one technically meters per second. Perfect. Okay, determine the distance traveled through the air when it is launched until it reaches the ground. So we actually want the distance traveled, like the actual distance traveled. What did I say was a formula for distance traveled from a certain time to a certain time? This. All right, so we want the distance traveled through the air until it reaches the ground. Okay, so when it is launched is at t equals 0, and when it reaches the ground, okay, it reaches the ground when the y value is 0. So the first thing I need to do is find out when is its y value or j value, whatever you want to call it, of its position 0. So minus 4.9 t squared plus 35t plus 9.5 equals 0. All right, what 2 times will we get? So we'll get time equals, now you'll get 2 values because it's a quadratic. Let's have a look what 2 values we get. But remember, time must be positive. Time has to be positive. So we have minus 4.9 x squared plus 35x plus 9.5. And we just solve. Okay, yep, we get 2 values. One of them's negative, one of them's positive. 7.4047. 7.4047. We rejected the negative time, okay? Now, maybe in the test you have to write comma and negative time and then reject, okay? Now, therefore, all I need to do is find out the distance traveled, and I just discussed the formula for distance. The distance traveled would be the integral from t1, which is 0, to t2 of 7.4047, and the absolute value of the magnitude of the velocity vector. If anyone forgot, I'll write it down again just for your convenience. This is the formula for distance traveled from t1 to t2. Okay, so t1 to t2, and we've got the 2 times. Then we need the magnitude of the velocity vector. The velocity vector was this, so we want the magnitude of this vector. The magnitude of this vector is square root of 12 squared plus minus 9.8t plus 35 squared. All right, that is the magnitude of the velocity vector. So we don't need to write that anymore, dt. And that should tell us the distance traveled. Let's have a look. We want the integral from 0 to this specific time of the magnitude of the velocity vector, which was square root of 12 squared, which was 144, plus, or was it plus minus 9.t plus 35. I'll just write x minus 9.8x plus 35 squared dx. That will tell us the distance traveled. Alrighty, they wanted to 168.47, but they wanted to 1 decimal place, so 168.5 meters is the distance traveled. Easy. Question 15. The diagram shows a right rectangular prism. Yep. Relative to vertex O, vertices A, B, and C have these position vectors. Alright, determine the vectors AD and CG. Okay, now obviously this is the x-axis. This is weird. They put the y-axis here. Usually that stands for the z-axis. But anyway, that's the y-axis, x-axis, and z-axis. And they said A has got the position A00. Now I want everyone to realize that this is an x value, B is a y value, and C is a z value. Okay, and that's the vertices of A, B, and C. So effectively, it tells us that this distance here is little a along the x-axis. This distance is b along the y-axis. So b along the y-axis, so that tells me that this distance here is b. And tells me that the c, which is along the z-axis, is c. Okay, fine. Determine vectors a, d. They want the vector a, d. Okay, so that's pretty straightforward, guys. You can theoretically, if you want, I'll just write arrows and all of this. So this is vector C, this is vector A, and this is vector B. So I'm just going to use my picture to come up with an expression from A to D. So to get from A to D, I guess I'll go from here to here, and then there, and then there. That should get me from A to D. So I'm going to go from A to O, plus O to C, plus C to D. Now A to O is just negative A, O to C is C, and C to D, everyone should realize, is the same as O to B, which is just B. So if I was to write this nicely, it is B plus C take A. That is AD. All right, CG, C to G. So AD is one of the diagonals, and C to G is the other diagonal. So to get from C to G, I'll just go there, there, and there. That should get me from C to G. C to G is C to O, plus O to A, plus A to G. C to O is negative C. O to A is just A, and everyone should realize that A to G is just the same as O to B, so it's just B. Okay, so if I write this one politely, it is A plus B takes C. Use a vector method to show that AD and CG bisect each other. Use a vector method to show that AD and CG bisect each other. So first thing I'm going to do is I'm going to find the midpoint. I'm going to say let X be the midpoint of AD, which is one of the diagonals, and let Y be the midpoint of the other diagonal. So the other diagonal is CG. Okay, we have to find, I'm going to let that be capital Y. Okay, so let's find what the midpoint of AD is and the midpoint. And when I say let's find the midpoint, I mean let's find the position vectors of the midpoint. Okay, so position vector means with respect to the origin. So I'm going to find out where OX is first. Now, I hope you guys realize what I'm trying to prove. I'm trying to prove that X and Y have the exact same position vectors. If X and Y have the same position vectors, it means that the midpoint of AD and the midpoint of CG have the exact same, like, middle point. Okay, So midpoint of AD is somewhere there. So let's keep it very simple. We want to find OX, right? So OX is the midpoint of AD. It is the midpoint of A to D, and I want to find out what OX is. I'm just going to go to A first. So I'll go from O to A, and then I'll go from A to X, and we just agreed that X was the midpoint of AD, so it's half AD. OA is just A, and we just worked out an expression for AD. AD was B plus C take A. Half B plus C take A. That becomes A take half A, so it literally becomes half A plus B plus C. That is OX. That is the position vector of OX. Now let's find the position vector of OY. OY is the midpoint of CG. So let's find the midpoint of OY. It is the midpoint of C to G. So first I'm going to go to C, and then I'll go midpoint. So O to C, and then C to Y. O to Y is O to C plus C to Y. We just agreed that Y is the midpoint of CG, and you have an expression for CG. A plus B takes C. A plus B take C. And if I add all that up, so that's C, take away half C, which is half C, and literally we end up with half A plus B plus C. Wow, that's pretty cool. The midpoint of AD and the midpoint of CG have the same position vectors. So we can write that therefore the midpoints of AD and CG are coincident. Alright, in brackets they have the same position vector. Which the rational, another way of saying that is that therefore AD and CG bisect each other. Simple. All right. Determine the relationship between A, B, and C if AD and CG are perpendicular. Now, guys, just knowledge about, like, I've got a feeling that it means they all might have to be the same, something like that. They might all have to be the same or something similar to that. Anyway, it doesn't matter. Find out when they're perpendicular. So if they're perpendicular, guys, we know that their dot product has to be 0. Okay, if two things are perpendicular, the dot products have to be 0. So this dot this has to be 0. And remember, they're not i's and j's. They are not i's and j's. Let's get rid of that. So if they're perpendicular to each other, we can write that AD.CG is 0. AD.CG is 0. So there's going to be something special that happens if the dot product is 0. So this dot, this is 0. Alrighty. And now let's just do the dot product. So that's B dot A plus B dot B take B dot C plus C dot A plus C dot B take C dot C. Take A dot A, take A dot B, and plus A dot C is 0. Now don't forget stuff we learned in year 11. We learned in year 11 that A dot A is just the magnitude of A squared. So in this particular case, we have B dot B, C dot C, and A dot A. And we also have, now, a few things are convenient. You should all remember from year 11. This is interesting. From year 11, you should remember that A dot B is the same as B dot A, which is different to this. Technically, A cross B is negative B cross A, but A dot B is the same as B dot A. So B dot A and A dot B cross out. So there's a lot of things that are going to cross out now. So B dot A and A dot B cross out. Then we have a minus B dot C and a plus B dot C. And we have a plus C dot A and, oh, that's 2 pluses. So those shouldn't cross out unless I've made an arithmetic error. Unless I've made an arithmetic error. AD and CG are perpendicular to each other. Let's have a look. We have C dot A, nope, they don't cross out with each other, blah, 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 blah. So I get stuck with that. Okay, so that's not seeming to work out. Now, I did tell you that there weren't I's and J's, didn't I? I did tell you there weren't I's and J's, but actually, they are somewhat I's and J's, are they not? So technically, at the end of the day, this is A is literally a measure of I's, B is technically a measure of J's, and C is technically a measure of K's, which means that theoretically I could write it like this. This could be written as equals to, now what was B at the end of the day? It's 0, B, 0. So this theoretically can actually be written as negative A, B, and C, because you could write it like that. And I guess in the exact same way, I could rewrite this as A, B, neg C. That's what I could do if I wanted to, because yes, I thought for a second they're not I's, J's, and K's, they're A, B's, and C's, but that's not, you could argue that A is technically just your measure of I's, because it is along the x-axis, B is measures of J's, because it's along the j-axis, and C is measure of K's, because it's along the z-axis. So that means that I can actually, so I tried this, that's the first thing I did, and then I stalled because I was getting, I was hoping lots of stuff would cross out, but a lot of things were not quite crossing out to each other. So instead what I did is that I am going to, or not did, what I'm going to do now is do it alternatively. So another way of writing A dot D dot C G is I can rewrite that as negative A, B, C dot, and this one was A, B, negative C. All right, what does that yield us? Let's have a look. By the way, I've just realized both ways actually work. In fact, both ways work. Let's do both ways. I'm just going to show you that had I stuck with what I did, it would have still worked just fine. Now, at the end of the day, we should also remember this from year 11. At the end of the day, what is the definition of A dot B? The definition of A dot B from year 11 is magnitude of A, magnitude of B, cos theta. All right, and we know that if A dot B is 0, it means that the angle between them is 90. Now, what is, I was thinking that, this is not good because this and this don't cross out. But if you think about it, isn't C perpendicular to A? C is perpendicular to A. This is 90 degrees to that. All right, which means that theoretically, I don't even care whether this, if I was to rub out all this, if I was to ignore all this, we should automatically know that since A is perpendicular to B, which is perpendicular to C, A is perpendicular to B, which is perpendicular to C, which means all these dot products are just 0 without even things crossing out. These are all 0, 0, 0, 0, 0. They're all 0, okay, because they're perpendicular to each other. So what do we get left with? We get left with B dot B, which is magnitude of B squared. Take C dot C, which is magnitude of C squared. Take A dot A, which is magnitude of A squared, is 0. So we get magnitude of B squared is equal to magnitude of A squared plus magnitude of C squared. Now remember, magnitude of C, the magnitude, so these are the vectors A, B, and C, and the magnitude of A is A, and the magnitude of B is B, because everything else is 0, and the magnitude of C is C. So really, I can rewrite this to just B squared equals A squared plus C squared. So what I'm trying to say is, had I done it my original way, it would have still worked out fine. Now this way is obviously quicker. This dot, this is 0, so this automatically gives you minus A dot A, which is minus A squared, so plus B squared minus C squared is 0, and that also yields us the same answer, that A squared plus C squared equals B squared. Okay, both work, wasn't worth many marks. But what made this question really strange, not strange, but different to the ones that I usually see, the ones where I usually see, they usually have like, if I was to explain to you the ones that I usually see, it's just some random things. So they'll tell you that this is A, and this is B, and hypothetically this is C. And none of them lies specifically along the X, Y, and Z axis. So none of them can you actually go from here to here. Generally, you can't turn A's, B's, and C's into a vector in component form and I's, J's, and K's. But for this question, purely because A, B, and C ran along the X, Y, and Z axis, we were able to change something from that form into component form. Okay? Perfect. Question 17. Plane 2 has got this equation. Fine. Determine the coordinates of a point that is closest to A. Determine the coordinates of the point that is closest to A. All right, really generic, straightforward question. Several ways of doing it, but I'm going to do it in the nicest possible way that we have. So we want the point on the plane that is closest to A. Okay, so there's your plane. A is somewhere over here at 1, 5, 4. And we want to know where on the plane is closest. Where on the plane? They don't even care what that minimum distance is. Remember, guys, this question is not find the minimum distance. This question is find the point that is closest to A. Okay. Now, what do you guys know about the plane? What information do we know about the plane? We know that the equation of the plane is r dot 2 neg 1 neg 3 is 13. So the information that we have about the plane is the normal to the plane. The normal to the plane is given by 2 neg 1 neg 3. Alright, which means that I can now create a line like such. I can create a line like such. So what is the vector equation of the line that I've just created? The vector equation of the line that I've just created is, now remember, vector equations of all lines are A plus lambda B. So A is a point on the line, which we can say is 1, 5, 4, plus B is a vector parallel to the line. Now the normal is parallel to the line. I know that it's in the other direction, but it doesn't matter. I could have done the arrow like this, I could have done the arrow like that, it doesn't matter. So what I'm trying to say is the bit with the lambdas is just the exact same, 2 neg 1 neg 3. Perfect. I've now found out the vector equation of the line, and I have the vector equation of the plane. Now, be smart. Use your ClassPad to maximum capacity. Now, I know you can manually work out where this hits this. The manual way of working it out, which I would not recommend anybody does, but the manual way to find the intersection of a line and a plane is to sub the line into the plane. So there will be a lot of people that sub the line into the plane. So the line is 1 plus 2 lambda, 5 take lambda, and 4 take 3 lambda. So we can sub that line into the plane equation. So 2 neg 1 neg 3 is 13, and you can solve for lambda. Now, like I said, this is not the smart way of doing it. There's definitely a much faster way of doing it. 5 take lambda, take 3, 4 minus 3 lambda is 13. And we can solve for lambda. 2 plus 4 lambda, take 5 plus lambda, take 12 plus 9 lambda equals 13. Now, what that gives us is this. 4 lambda plus lambda is 5 lambda plus 19, 14 lambda. We have 14 lambda. 4 plus 5 plus 14 lambda. 2 take 5 is neg 3. Neg 3 take 12 is neg 15. Bring that to the other side. 13 plus 15 is 28. We're lucky we get a nice number. Lambda is 2. Then we now know what lambda is. So if you want to find out where on the line it hits the plane, we can sub lambda equals 2 into here. So if I sub in lambda equals 2, we get, I'm just subbing in 2 into here, which is as good as subbing it into here. So when I sub it into here, 1 plus 4 is 5, 5 take 2 is 3, and 4 take 6 is negative 2. Perfect. That is the point at which the line is closest to the plane is closest to this point right here. Now, I did say that this is not the smartest way of doing it. What would be the smartest way of doing it? Save yourself some time. What is this? This is the equation of the line. Get it in, it's in vector equation form. Get it in Cartesian form. So in Cartesian form, it's this. X is 1 plus 2 lambda. Y is 5 take lambda. And Z is 4 take 3 lambda. And then what's this? Get this one in Cartesian form. In fact, it was in Cartesian form. 2x take 3y. 2x take 3y, sorry, take y, take 3z equals 13. Alright. Now you can put all four. All you'd have to do is just put these four into simultaneous equations on your ClassPad, and it will automatically spit out the answers for you without having to do any extra effort. You'd have to do 0 extra effort, and it will give you the line. So x is 1 plus 2 lambda. So watch what I do. X is 1. We need a fourth variable this time. Simultaneous equations, 4 equations. X is 1 plus 2 lambda. I'm just going to write 2. I don't know whether it accepts you to. I'll just write it from here. X is 1 plus. Keep doing the same mistake. Hold on. Variable. So I don't know whether it likes you to put in a constant or not. So x is 1 plus 2 lambda. Alright, just glitching. Hold on. X is 1 plus 2 lambda. This is better. You can write W for now. X is 1 plus 2W. Then we have y equals, what was the equation for our y? Y was equal to 5 take lambda, 5 take W. And then we had z equals 4 take 3 lambda. So 4 take away 3W. And then we had the Cartesian equation of the plane. The Cartesian equation of the plane was 2x take 3y take 3z equals 13. And we can write x, comma y, comma z, comma w. Perfect. That should hopefully give us an answer. If I've typed it in right now, let's make sure I've not made a mistake. X is 1 plus, let's just check. X is 1 plus 2 lambda, 5 take lambda, 4 take 3 lambda. 5 take lambda, and 4 take 3 lambda. 2x take 3y, take 3z is, I've typed in something wrong. X is 1 plus 2 lambda, y is 5 take lambda, z is 4 take away 3 lambda. Yeah, that's all right. And the equation, 2x take y. 2x take y take 3z is 13. Perfect. And there you go. You literally get the intersection point straight away, and you get the lambda value. X is 5, y is 3, z is -2. What happens if I didn't write w? Would it still get it for me? It still does it. Even if you don't want w, it still gives you x is 5, y is 3, z is -2. Alright, x is 5, y is 3, and z is -2. So you can see that was so much quicker than having to sub the line into the plane. To find the intersection of line and plane, that is the fastest way to do it, if you have ClassPad allowed, is get the Cartesian equation for the lines, not Cartesian, the parametric equation for the line, and get the Cartesian equation of the plane, sub them all in, and it will just spit out your answers for you. Okay? Perfect. That's how you find the coordinate that is closest. Now remember, that is different to the alternative question. The alternative question is this. The alternative question is this. Determine the minimum distance. Determine the minimum distance between the plane and A. Between the plane and A. That is the alternative question type. All right, now you could use this technique to find the minimum distance. Having said that, this is a bit lengthy, but how many lambdas you started here? Your line started here. How many lambdas did you have to move before you hit the plane? You had to move 2 lambdas. And how big is the lambda? So I'm just going to find out on the side, even though it's not asking it, what the minimum distance is. The minimum distance is 2 times the magnitude of this vector. 2 times the magnitude of 2 neg 1, 3. So 2 neg 1, 3 is 2 squared is 4 plus 1 plus 9. 9 plus 1 is 10. 2 root 14 is the minimum distance. All right. So you can use this technique to find the minimum distance. It's just not the fastest way of finding out the minimum distance, but we can still use it to find the minimum distance. All right, this would be the fastest way to actually find the minimum distance if you didn't care about which point has to be closest to it. So watch what I do. We want to find just the minimum distance between the point and the plane. Alrighty, so we don't need to create a line like such. What you do need to do is this. You need to find a random point that exists on the plane. What is a random point that exists on this plane? A random point that exists on this plane is anything that satisfies this equation. The easiest numbers to do is 0, neg 13, 0. That is a point that lies on this plane because it satisfies this equation. So, what is an expression for this diagonal? An expression for this diagonal vector is just one take the other one. So the expression for this diagonal vector, I'll just make everything really clear. I found a random point that lied on the plane, and I used the random point that lied on the plane to find an expression for a vector, the diagonal vector between a point on the plane and the point itself. So the expression for that diagonal vector is 1, 18, and 4. That is the vector. I'm going to call that vector A. Now, we know that this is not the minimum distance. In fact, the minimum distance would actually be like this right here. This right here would actually be the minimum distance. And I hope you guys realize that D is the scalar projection of A onto N. It is the component of A that is parallel to N, but just the size. And what's our formula for scalar projection of A onto N? A dot N divide magnitude of N. If you get a negative number, you just make it positive. So what is our vector A in this case? 1, 18, and 4. And what is our vector N? Our vector N is 2, neg 1, neg 3. So this divided by the magnitude of the normal should give me the minimum distance. So 2 squared plus 1 squared plus 3 squared. All right, that's 2. Take 18. Remember, if you get a negative number, you just make it positive. Take 12. All over, this is root 2 squared is 4. Plus 1 is 5, plus 9 is 14. What does the top become? 2 take 18 is minus 16. Minus 16 take 12 is minus 28. All right, like I said, if you get a negative number, we just drop it to find the minimum distance. And to rationalize it, we just timesing the top and bottom by root 14. So if you times top and bottom by root 14, you get left with 28 over 14 is 2. We get left with minus 2 root 14. So the minimum distance is that, but again, we make it positive, so therefore the minimum distance is the positive version of that, so positive 2 root 14. What did I get before? Also 2 root 14. All right, so one question just is to find the minimum distance, and the other question type is find the position vector of the point that is minimum distance. So there are 2 different question types. Please be aware of the 2 different question types. Okay. Part B, vector V lies in the plane and it's perpendicular to this line. Okay, fine. Vector V lies on the plane and it is perpendicular to this line right here. Fine. Find the values of A, B, and C, given that A is more than C. The fact that they're giving me this makes me think there may be multiple answers, and I just have to pick the answer that works. So, vector V lies on this plane, so we can just say that hypothetically this is vector V, for example. That is vector V, and it is perpendicular to this line. It is a vector that lies in the plane, and it is perpendicular to this line. Fine. I hope you guys realize that this is normal to the plane. So yes, it's normal to V, but there are so many things normal to V. This would also be normal to V. There are lots and lots of things that could possibly be 90 degrees to V. It's not just this vector here that's 90 degrees to V. They've given us the Cartesian equation of the line. So if I was to write this a bit better, it means lambda equals x plus 1 on negative 1. They're all basically equal to lambda, which equals to y take 3 on 2, which equals to z take 1 on 2. So for what I'm trying to do is convert the line from a Cartesian form to a vector form. So if I convert this to a vector form, let's just rearrange for x. If I use this to rearrange for x, I get x is minus lambda take 1. I'll rearrange for y by letting this equal this. So if I rearrange for y, it is 2 lambda plus 3. And if I rearrange for z, the rearranged version for z is, if I rearrange for z, that would be 2 lambda plus 1. So, effectively, another way of writing the equation in this plane, this line, is r equals negative 1. Remember, the lambdas are this, and this is the bit without the lambdas. The bit without the lambdas are negative 1, 3, 1. Plus lambda lots of neg 1, 2, 2. That, guys, is the vector equation of this line here. Alright, this is the vector equation of this line here. Okay, perfect. So if it's the vector equation of this line here, and we know that vector V is perpendicular to this. Vector V is perpendicular to this. If it's perpendicular to this, it's specifically perpendicular to the direction of this line. It is perpendicular to neg 1, 2, 2. Now that's what I was trying to say before. A lot of people will think that, if we're perpendicular to V, it has to be this vector here. Alright, yes, I agree this vector is perpendicular to V, but remember, there are a whole bunch of other vectors that could be perpendicular to V. And here is obviously one of them. Neg 1, 2, 2 is a vector that is perpendicular to V. So one equation that I can come up with is this. I can come up with A, B, C dot this vector here, which is neg 1, 2, 2, and that dot product has to be 0. So we basically get negative A plus 2B plus 2C is 0. So that is one equation that we have. Now, another equation that we have is that the magnitude of vector V is root 26. The magnitude of this is root 26. So what information have I used? I used the fact that it is perpendicular to this line here to come up with that equation right there. Alright, now I'm using the fact that the magnitude is root 26 to come up with this second equation, that a squared plus b squared plus c squared is root 26 squared. So that is a second equation. And thirdly, what information have I not used yet? I've not used the information that vector v lies in the plane. Vector v does lie in the plane. Now, if vector v lies in the plane, it means that vector v is also perpendicular to 2, minus 1, 3. Alright? Vector v has to be perpendicular to 2, minus 1, minus 3 as well. So let's write that down. Vector v, which is a, B, C, yes, it's perpendicular to something else that we're trying to find, but it is also yes, it's perpendicular to this line here, aka this vector here, but it is also perpendicular to the normal, which is 2, -1, -3. So that is another equation that's going to yield. So this can be rewritten as 2a take b take 3c is 0. That is our third equation. And there you go, 3 equations, simultaneously solve it, and only pick the answer where a is more than c. So let's have a look. So one equation that we have is that we have 2a. I'm just gonna write it in terms of x's. So we have minus x plus minus x plus 2y plus 2z equals 0. So that is one equation. Another equation that we had was x squared plus y squared plus z squared is equal to 26. And the last equation that I came up with was 2x, technically b, 2a, take b, take 3c equals 0. And then we have x comma y comma z. All right, we get a very nice set of answers. -4, 1, -3, and 4, -1, 3. They're basically the reverse of each other. So let's just write both answers down. So one set of solutions that we get is that A equals 4, B equals -1, and C equals 3. And the other answer we got was the exact opposite of it. So A was -4, B was 1, and C was -3. Alright, however, it says A is more than C. So since A has to be more than C, as A is more than C, we must therefore go with this answer right here where A is more than C, okay? Over here, A is actually less than C. So the answer is A is 4, B is -1, and C is 3. I think the hardest part of that question was turning this into parametric / vector form, so you could find out the vector that was actually perpendicular to. Okay? Perfect.